Right, now simplifying a cos x plus or minus b sin x, folks. This can look a little tricky. This is stuff that's not in the formula booklet, but don't worry too much about trying to remember everything that you see here, because a lot of this is given in the format of all the questions that they ask. Now, if you look in the textbook about how to do this stuff, it could fry your mind quite massively. Now, normally I'm not one who goes for tricks, but when Mr. Cooper showed me this little trick, I thought, yeah, this is going to make life a lot easier. So you can copy this bit down if you like. It might not be a bad idea, but then I'm going to pause the video to do that. Then if you could copy down this question and then get ready to watch how we go through it. Now, as I explained it on the first one, after that, if you pause it and have a go at doing the second attempt at it, hopefully all should be not too tricksy. Before we go into that as well, I'd just like you to think about what would happen if you tried to draw the curve that was 3 sin x plus 4 cos x. In fact, it would be really nice if you got your calculator and you did 3 curves. You could do y equals 3 sin x. You could do y equals 4 cos x. And you could do y equals 3 sin x plus 4 cos x. Put those into your calculator and see what you come up with. Okay, I've just done that, and starting off with just a normal trig boundaries, and then use on B window, and then I just changed it, instead of being from +1 to -1 to +6 to -6, and you start to see a bit of what's going on here. So first of all, oh sorry, why does it do that? Right, okay, so first of all, the blue line is the sine curve, is 3 sin x. The pink one in the middle there, that's 4 cos x, and then the green one is the 3 sin x plus 4 cos x. And if you look very carefully, you'll see that the top of the wave gets at 5. But essentially, they're all basically sine waves, aren't they? So I'd like you to think about the fact that they're all sine waves, and the fact that the magnitude is just getting sort of bigger each time. So the magnitude of the wave is changing. When it's 3 sin x, it goes to 3. When it's 4 cos x, it goes to 4. And when it's 3 sin x plus 4 cos x, it goes to 5. Now, where can you remember ever seeing 3, 4 and 5 together at one time? I wonder. Right, so we are starting with this. So let's put it in this form. So 3 sin x plus 4 cos x, and I'm putting the 3 sin x first because it's sine there. Now that's very important, and that's going to be equal to, or identical to if we want to, r sine x plus alpha. Right, now the little trick we're going to do is we're going to draw a right angled triangle. That wasn't a very good one, was it? Never mind. There's my right angle. This alpha angle here is going to be added to x. That's going just down here. Now I said I'd put in the sign at this end. I'm going to take the number that's with the 1 at the left hand side. That number is going round there to be on the adjacent side. This one is coming round to go on to the opposite side. Now, if we were going to work out this angle, what would we do? We would be going adjacent, opposite. That sounds like a tan to me. Tan alpha is going to equal the opposite over the adjacent. So that gives us tan alpha equals 4/3. And then if I pop in shift tan 4/3, I get 53.13 something equals 53.1 degrees, and it does say it's got to be between 0 and 90, so we don't need to worry about drawing any curve. So there's the alpha one, and the second one is for the beta. So have a little go at the cos now and see if you can do that. Alright, so hopefully you've had a go at that. Now we'll do the cos one over here. So I've got, I'm going to write 4 cos x first of all, because it's the cos, I put the cos first, plus 3 sine x, and that's going to be identical to r cos x minus beta. At which point I realise I've forgotten to do the r. Now what is the r? The r is the magnitude. Remember we had 5, didn't we, on the thing when it was there? It's actually the hypotenuse that we're doing. So r is going to equal the root of 4 squared plus 3 squared, which is 5. So our final thing, our final answer that I should have put down here is that 3 sine x plus 4 cos x is equal to 5 sine x plus 51. So sorry about that. You may want to pause again before you complete what you've done over here. So I'm going to draw myself a slightly better right angle triangle this time. The beta is still going down there. The 4 goes down to here. The 3 goes across to here. So this time we've got tan beta equals opposite is 3 over adjacent is 4. And then I just need to chuck in tan inverse of tan 3 over 4 press equals 36.86, so that rounds to 36.9 degrees. And then we are still going to have the r being the root of 4 squared plus 3 squared, which is 5. So we can say that 3 sine x plus 4 cos x, if you've written it the other way around, it really doesn't matter, is equal to 5 cos x minus 36.9. And you'll notice that we've got something pretty similar here, and that's because the magnitude of the wave is going to be the same, but in this case we're going to have to add 51 because that's going to shift the sine wave 51 degrees to the left along the x-axis, whereas in this case at negative 36.9 ends up having the reverse effect and moving it 36.9 to the right, and that's because there's 90 degrees difference between sine and cos. I say 90, that's because I should have got 53.1 in there. A load of mistakes in here, aren't there? But that adds up to 90 because that is the difference, isn't it, between sin and cos? They're on the other side of your 90-degree angle. Right, that is all of that problem. But there's a few different kind of situations we can have here. Now it's all the same, so take your time, pause the video, have a little go, do the same thing with the triangle, take it as far as you can, see if you can sketch the graph. So what we should be doing, we start off by saying, oh, it's a sine one, so I'm going to have sine x take root 3 cos x in the form r sine x take alpha, and we're going to start, that's 1 sine x, isn't it? So there's a hidden 1 there, so that's a 1, and I've got root 3 there. We ignore negatives, by the way. And the name of our angle this time is alpha. So what are we going to have? We're going to have tan alpha equals opposite over pi root 3. That's a familiar one, isn't it? If you do tan inverse of tan root 3, we should get an angle that we've seen before, and we do. We get 60 degrees. Only problem is the question's asking it in terms of that. Now pi is 180, isn't it? And 60 is a third of 180, so that would actually be pi over 3 radians. What else do we need to know? And that is between 0 and pi over 2, so that's nice. We need to know the r value, don't we? So we need to know the hypotenuse. So this is going to be the square root of root 3 squared, which is 3, plus 1 squared, which is 1. So the root of 4, which is 2. So we get sine x take root 3 cos x is 2 sine x take pi over 3. So that's part A done. Part B, to sketch the graph, what we're going to need to do is we're going to need to think first of all about a sine curve. So I might just do my little normal sine curve, and we're only going, actually it doesn't say, that says between that and pi over 2 up there, but it doesn't actually mean for the question. It's a slightly badly worded question. So there's my 360 degrees that I would have, and I'm just going to go on a little bit further each side so that I can get a real idea of what's going to happen, because what we are going to get, that's 1 and negative 1, isn't it? Because we've got a magnitude of 2 there, we're going to be going up to 2, down to negative 2, and then we're going to be having minus pi over 3. That means that we're going to shift us to the right a third pi. Now that there is pi, isn't it? So a third of pi is going to be about there, and it's going to then cut the axis about a third of pi further, well, not about, exactly 4/3 of pi there, and then that's 2 pi, so we're going to be needing to go on 6 plus 1 is 7/3 of pi, so that being 2 pi there. So we are saying that that's where we're going through, and that's where we're going through. Halfway between there will be about there, so it's going to be pointier, and it's going to be doing something looking like that, and then so that one there is y equals sine x take root 3 cos x, and if we make that the one that we ink in, then we know we've gone right. Of course you can bung it into there just to help you out, but remember to put it into radians mode first. Right, there you go. We've just got 2 more sets of these to do, folks. Excited? You should be. Write this one down, pause the video, have a little bit of a go. It's all the same thing each time. Really like tricks, but I do like a good trick. I like a trick when you should really, if you haven't looked at it already, have a little look in the textbook, see what they want you to do, because when you realize just what a headache this is saving you, that's when it makes you really quite happy to do. So there's my little right angled triangle. I do want it in cos, and I've got cos first of all. I didn't check that before I wrote it down, so always watch out for that. So the 2 goes down to there, the 5 goes across to here. We have tan alpha, there's me alpha, equals 5 over 2. So alpha equals inverse of tan 5 over 2 gets me 68.2 degrees to 1 decimal place. The hypotenuse of this is going to be 25 plus 4, isn't it? 5 squared plus 2 squared. So that is r being root 29. So we can say here 2 cos alpha plus 5 sin alpha theta equals root 29 cos theta take 68.2 degrees. And then it wants us to use that to solve this equation. So have a little pause, have a think about it. So this equation equaling 3 means we can say that this here equals 3. We can divide by root 29, which gives us cos theta take 68.2 degrees equals 3 over root 29. And that means that theta takes 68.2 equals cos negative 1 of 3 root 29. Now if we do that, we get, in the calculator, you get 56.1 degrees. Now you've got to be careful here, because this is a transformation of the graph. So you can't just add 68.2. You get one right answer, but not both of them. And part of the reason is because you've got to think of the whole graph being shunted. So let's just look at what we've just done, which is the cosine wave like that. 56, but there's 90 degrees, isn't it? So 56.1 is going to be about there. Now when this negative 68.2 takes effect, that's going to add 68.2, isn't it? That means the whole wave is going to be moving on like that. And that means that inside our 360, 0 to 360 part, we've actually got part of the wave coming in. That was over here. And there was a sneaky little guy just there that's going to come across and be within on there and there. So the first thing to do is to think that this sneaky guy, where's he come from? Well, before it moved, he's the same distance the other side. So equals 56.1 and negative 56.1. And then we are going to add 68.2 to both of those. So negative 56.1 plus 68.2, and 56.1 add 68.2 is going to give us 124.3 degrees for that one, which is actually the more obvious one to get, and 12.1 degrees for the other one. So those are our two answers. Okay, last problem before I give you some of the exercise to have a crack at. So same thing going on. the function is that they want it in the form cos minus alpha, so that tells you what you're going to put first. See if you can find the maximum value of the function of theta and the smallest positive value at which it occurs. So let's do part A first. Pause the video, have a go. So it's in the right format already, so I can stick my 12 down to there, my 5 there. My R value I'll do whilst we're at it. 144 plus 25 is root 169, which is 13. So I know that R equals 13. I know I've got tan alpha equals 5/12. So alpha is the inverse of 5/12, which is shift tan 5/12, 22.6 degrees. And that means we can pop it in the form. So we're saying, right, 12 cos theta plus 5 sine theta is going to be R is 13 cos alpha take 22.6, and we've done part A. So now to think about what the maximum value is going to be and the smallest. Well, if it was just a normal cos curve, that goes between 1 and -1, doesn't it? So that would be doing that. If you multiply, if you've got 13 there, do you remember what happened on the first one? That R number was how far it's going. If you multiply our basic transformations, it's going to give us stretch on the y-axis 13 times the amount. So the maximum value of f theta, max value, is going to be 13. And we want to know the smallest positive value at which it occurs. So have a little think about what's going to happen to our thing. It's going to move, if it's negative 22.6 degrees to the right. Now it's at its maximum at 0. So the smallest positive value of theta should be 22.6 degrees. And that's the whole question sorted. So I hope you found that entertaining and insightful as well as informative. And we'll move on to a little bit of practice now. So it's exercise 7E, page 184, questions 1, 3, 6, 7, 9, 10, 12 and 13. Enjoy all of that, my friends, and see you soon.